Looks like we're live. We've got about looks like about 20 minutes before the solar eclipse actually starts. Ooh, I've got 5 people watching now. Who's here with me? Join in on the chat screen. I know I'm one of them, so that means 4. You're looking at a live view of the sun right now. Let's take the sun full screen here. Got a huge magnetic storm, which is the sunspot there that you see right below center of the sun. It's been very active, causing a lot of solar flares. Not a lot going to be happening until about 9 minutes after 2. 9 minutes after 2 local time is when the partial eclipse is set to begin. But you are looking at a live image directly from the telescope right now. It's a little warm outside, so it looks like it's bubbling around a little bit there. Hi, Paul. Welcome to the broadcast. Where are you from? I'm watching my chat screen here on another computer while I'm running the broadcast here on the main screen on the main computer. Any questions, just type them in. I'll try to answer. I'm not a professional. I'm just an amateur at this, and I just like sharing with people. It's always cool to share this kind of stuff with people, especially in parts of the world where it might be either cloudy or just not visible, just because a solar eclipse is not visible everywhere at the same time. This is a ground-based camera. Yeah, actually I have a 12-inch Meade Schmidt-Cassegrain telescope. It's right outside the door here on my balcony. I'm in the comfort of my master bedroom here. I've got a Canon 5D Mark II hooked up to it and feeding the UK. I think you're gonna win the long distance award today. Great. But yes, it is just a 12-inch telescope right here on my balcony. In fact, I will, since nothing is happening just yet, let me grab my webcam and I will stick it out the door here so you can kind of see the setup. It's kind of a little, gotta open the door first. And let me switch to my webcam input here. So it's going to be a little blown out here probably, but that's the telescope. That's the camera end of it. I've got solar filters on the finder scope and also at the head end of the main telescope. Let me see if I can reach out the door here with this webcam and point the camera back towards the front of the telescope. Of course, now I'm out here on the balcony and I can't see my monitor, so I have no idea if I'm pointing at things properly for you, but I think you get the idea. We'll go back inside and we'll go back to the live feed. Camera's drifting a little bit, so as soon as I get this webcam set down, I'll reposition it. So if you're in the UK, are you somehow part of my wife's clique of friends that live over there, or are you just a random UK visitor that's found my page? My wife has several friends that live throughout the UK. she's at work right now. So is Paul the only one that's going to chime in? Tell me who you are and where you're viewing from. Another kind of cool feature with the software that I'm using here, I can actually invert the image, and it creates this sort of reverse image that actually shows the sunspots really, really well, especially this gigantic magnetic storm here that's right in the center of our view. Hoping I can grab a couple of screenshots of that view once the eclipse starts. We'll go back to real color image directly off the camera now. And as you can see here, I've got some information about the eclipse timings here. The closest city I could find was Las Vegas online, and according to this information it starts at 2:11, but I was able to find another website that gave more accurate information. 2:09:27 is when it's scheduled to start here. So we still got, what time is it? 1:51 now. We still have about almost 20 minutes to go. 3:30, 3:29 here in Henderson is going to be maximum eclipse. Unfortunately, it's just a partial. It's not nearly total eclipse. Should still be pretty cool though. I think about 40% of the sun will be covered by the moon, and it ends at 4:41 local time. Random visitor. You're just a random visitor. Okay. I'm pretty sure my wife is at work watching right now, and maybe she'll chime in here, and if she is watching, and she'll mention where her friends are at that are in the UK. Got a whopping 9 followers, right? 9 watchers right now. And Paul's the only one that's not shy enough to tell us who they are or where they're from. I was a little worried about the weather. We had a lot of cloud cover last night. Luckily it was just some high cirrus clouds though that typically burn off during the day here in the heat of the desert, and they have for the most part. Still a little partly cloudy out there, but they're real thin high cirrus clouds though, and so the sun just beams right through them. Might notice a little bit of information, a little bit of cloud cover whenever we actually switch to the whenever a cloud actually passes in front of the sun here. My alignment is just a little bit off. Well, any other questions, Paul? I can actually zoom in on this large sunspot here. Let me lock in here. I can go in 5x power here. We can get a really good close-up of this magnetic storm here. Ah, Peachy from Massachusetts. Nice. Welcome, Peachy Keen. So you're looking at a close-up of this magnetic storm here now. We'll go full screen with it. The camera's outputting at about 15 frames a second, and so you're seeing a lot of bubbling around there. Distortion probably from the heat, not on the sun itself, although I'm sure some of that is the sun bubbling around. But most of that is just heat in our atmosphere between the telescope and space. We'll go back I set up the telescope yesterday, and I took a couple of still images of this close-up of this magnetic storm, and then I also did the same thing this morning. So I've got a little animation here that I'll share with you that shows a little bit about how these storms grow and intensify and dissipate over time. About 20 hours difference here between 2:30 yesterday afternoon and almost 11 a.m. this morning. It's just a little animated GIF clicking back and forth between the two images. I tried to line them up in Photoshop here as best as possible. You can definitely see some changes in the shape of the storm though. That central dark spot, the very, very dark center portion there, is called the umbra. That's the center. And interesting fact about sunspots is they appear like they're black, when in reality they're not. If you could just isolate that tiny black portion there, it would be blindingly bright. The reason it appears black is because that central area there around the magnetic storm is about 5,000 to 8,000 degrees cooler than the surrounding area, and so that's the difference between 5,000 to 8,000 degrees in temperature. You're welcome, Blanca. Where are you from, Blanca? We have Paul in the UK, from the UK, and Peachy's from Adams, Massachusetts. Go back to our live view here. You're looking at a live view of the sun, and I will give you a close-up of that sunspot that I just showed you the photograph of. It's a pretty intense magnetic storm there. It's coming up on 1:58 almost. The eclipse is scheduled to start at about 2:09. So we've got about 12 minutes or so. Any other questions? Go back to the live view here. So I am going to occasionally bounce off of the live view from the camera, because I don't know if any of you are familiar with digital SLRs, but if you're in live view mode, which is what I'm doing, and all I'm doing is taking the output of the digital SLR, if you're not actually recording, as a safety feature, because the sensor will heat up over time, about every 12 minutes or so the camera will shut down on its own. So what I'm trying to do is to avoid the camera from shutting down, because if the camera sensor shuts down, I've got to go outside to the telescope, manually turn the camera off, and then turn the camera back on. So I'll bounce over to a graphic like this every once in a while, and turn the camera off temporarily. I do have a picture of the telescope set up. This is not a live view of the telescope right now. This is a picture that I took during the annular solar eclipse back in May of 2012. But you can see the main telescope there with the solar filter attached to the front of it. It's actually the only part of the filter that's allowing light in is that small round circle that you see sort of off center. The white portion is actually a solid sheet that blocks all the light, because the reality is that tiny small circle, which is a mylar solar filter material, that's all you need as far as light transmission through the telescope to to get a decent image like we're looking at. But this was taken up in the Wayne E. Kirch Wildlife Refuge, about, I'd say, 150 miles north of Las Vegas, May of 2012. So we'll go back to our live view here and check things out. Got to make a little minor positioning adjustment here. It's 2 p.m. We have about 9 minutes before our eclipse actually starts. I do have a little animation here that I can share with you that's going to kind of show sort of what's going to happen. This was created from a website online that just kind of, if you look at the time up top there, this will give you a bit of an idea of how much of the sun is going to actually end up being covered here from my view in Henderson, Nevada. I know the Griffith Observatory in the Los Angeles area is also covering it live here on Livestream. We're pretty much the same latitude though, so their coverage is going to be almost identical to mine. Obviously a bigger telescope and probably a lot more technical information. Not that I want to lose any of my 9 viewers that I've got. But alright, we'll go back to our live view of the sun here. Just to give you an idea of the size of our nearest star here, that sunspot that we're looking at, which I will zoom in on closely here, that sunspot is about 25 times larger than the diameter of the Earth. It's a pretty amazing size. The sun's about 1.3 million kilometers in diameter. You could fit inside the disk of the sun, or inside the globe of the sun, approximately 960,000 Earths. Just to give you an idea of just how puny we are here. And if you actually were to squish the planet to fill up every void, you could fit about 1.3 million Earths inside the volume of the sun. The sun's considered a yellow dwarf star. It's actually a very average star. There are a lot of stars out there that are much smaller and cooler than our sun. And there are a lot of stars out there that are much, much, much bigger. In fact, there are some stars that are so much bigger than our sun, it would be the equivalent of the size of the Earth and the sun. The Earth would be, or the sun would just be a tiny little speck compared to the size of some of the other stars that are out there. Eventually, the sun is going to start burning up all of its fuel, and it's going to start expanding, and it'll actually expand out beyond Mercury's orbit. It'll consume Mercury, then it'll extend out, it'll blow up, and it'll extend out beyond Venus's orbit. And they really think that it will actually blow up large enough to consume the Earth. Luckily, that's a few years from now. I don't think any of us have anything to worry about. 2:04. It's 2:04. We've got about 5 minutes before our eclipse starts. Another interesting fact about the sun. I'm gonna jump off this page for a second and let the sensor cool down just a little bit before we actually start with the Eclipse. I'll just put this up sort of as a placeholder, or show the animation here again. Another interesting fact about our sun: if you took the mass of everything in our solar system, all of the planets, all of the asteroids, all of the moons, all of the comets, everything that's in our solar system, if you took all of that mass, including the sun actually makes up about 99.86% of all of the mass in our entire solar system, which to me, that's just crazy, but that's a fact. Anybody know how long it takes light to reach the Earth from the sun? So if the sun was to somehow blow up right this second, how long would it take before we knew about it? Anybody want to chime in with the answer? All right. About 2 minutes before the eclipse starts. Mays, you are correct. About 8 minutes. It takes 8 minutes. Traveling at about 300,000 kilometers per second. It takes about 8 minutes. 8 minutes and 20 seconds roughly for the average distance of the Earth. This is a little animation, a close-up of that gigantic magnetic storm that we're viewing here on the sun right now, taken yesterday afternoon around 2:40, and then this morning again closer to 11 a.m. A little blink comparator between the two to show a little bit of the change in the shape of this storm. It's similar to a typhoon on Earth or a hurricane. It's going to change shape over time. It's going to expand and contract, and eventually it will just kind of fizzle out, just like storms here on Earth do. All right, time to go back live here, back live to the sun. I am going to actually turn that off just for 1 second. Nope, not the way I wanted to go. And I'm going to capture an image of the sun here just before it starts. Unfortunately, in order for me to take a photograph of the sun, I have to get out of live view. So we're gonna have to do that about every 10 minutes or so. We'll go back to live view now. I've got a picture right before the eclipse is scheduled to start. My alarm for 2:09 is going off, so we should actually be seeing the beginnings. Well, Peachy, I don't know the answer to that. I think not, because the moon is much closer to us, and it's actually the moon's silhouette that we're seeing. So the eclipse is probably, I forget how long it takes light to reach the Earth from the moon. Only a few seconds, I believe. I am going to go to an inverted image here because this, I think, will make it a lot easier for me to see. Oh, I think I see it right around in this area here. The sun is starting here, so let me go in here and capture an image. Looking at the sun disk here as a clock face, 12 o'clock being straight up. If you look here in the about 2 o'clock position, you can just start to see the moon coming into view here. So our eclipse is officially underway. So like I said, I am going to be stopping the live view probably every 10 minutes or so to let the sensor cool off and also to capture a still image. Bemets, you know, I don't ever recommend that. It really depends a lot on the conditions at sunset where you're at. If the sky is really clear and there's no cloud cover at all, no haze, and you've got a view right down to the horizon, you know, it's just like any other time. If you look at the sun, if it hurts your eyes, then you're doing damage to your corneas. So I don't really recommend it. If you've got really dark sunglasses, like ridiculously dark sunglasses, and even a couple of pair that you could double up, and even then only when it's very close to the horizon. You know, there are times when there's enough haze and enough you know, just junk in the atmosphere that you can look at the sun when it's close to the horizon. Right now, I don't know where you're at, but it's, you know, the sun is very high in the sky. I wouldn't even think about going outside right now and looking at the sun. It's just so dangerous. I am going to do another capture here since we've got a little more progress. So when I go into capture mode here, what's going to end up happening is you're going to be viewing temporarily the last image that was taken, and then it will load the latest image as it just did there. So I'm going to let it take a couple of shots here. So I guess getting back to your question, you're not going to hear me say, yeah, sure, it's safe to go out and look at the sun at sunset, because it really all depends on the situation. Alright, we're back in the live view mode here. I really like this inverted look. In fact, I'm going to try to grab a screenshot of that right now. Sorry guys. I wish this would open up on another screen so you don't have to see that, but we'll get back into our live view here. Compared to, you're in the southeastern US. Okay. Moon's much lower on your view. The moon is much, I'm not sure I'm understanding. Oh, well I understand what you're saying. The angle of the position of where the moon appears to be chopping into the sun here. Yeah. You know, it all has to do with the tilt angle of the camera. I could go outside and I could loosen up the camera attachment and rotate it and and make the sun be coming in directly from the top. I've actually just got it set up sort of at a natural angle of if I were looking through the telescope eyepiece, this is the angle I would be seeing right now. So the camera is more or less pointing straight up and down. And the Griffith Observatory, their telescope is also on an equatorial mount, which sort of changes everything. My telescope is on an alta-azimuth mount, if you're familiar at all with telescope mounting systems. So my telescope basically goes up, down, left, right, whereas the Griffith Observatory telescope on an equatorial mount is sort of just tracking the sky, tracking the sun across the sky left to right, because of the type of mount that they've got. Equatorial mount and alta-azimuth mount are the two different mounts that we're dealing with here. And again, just the mounting of the camera, I don't know what type of, if it's a video camera or if it's a digital SLR like this that they've got attached to the end of their big telescope. It's probably some sort of video camera. Theirs could just about be, my wife finally chimed in from work. Hey, baby. Eclipse has started, as you can see. Everything's going good with the broadcast. I am going to stop for 1 second here and grab a couple more images. Okay. My wife has jinxed the whole operation. The software just crashed. I'm just kidding. It's actually crashed before in the past. So what I'm going to do is I'm going to go temporarily to this little animation or this little graphic here that shows the animation of what's happening, and I'm going to get out of this software, reboot it, and get everything going again. This is the first crash today during the lunar eclipse broadcast. A couple of weeks ago I had 3 or 4 crashes throughout the course of the night. I'm not sure. The software runs very stable when it's running by itself, but in order to broadcast this stuff live, I've got to be running 3 different pieces of software. And wow, it did a hard crash here. It's not letting me dump out of this and restart it. Come on. Alright, I'm getting technical advice from my AV support crew here. Okay, Joni, I got your text message. Yeah, it is distorted, and I had the same problem during the lunar eclipse. I will try to back the mic off a little bit here. Tell me if it's any better. I'm really not liking that this software has crashed hard on me here. I don't want to have to reboot the computer, because if I reboot the computer, I'm going to lose all of you here until we can get back up and broadcasting again. I'll turn the sound down on the mic, or the mic level down on the microphone there. Alright, let's try one other thing here to get this thing going. Okay, thanks, Joni. Audio's better. Excellent. Let's see. Okay, so now I've got the camera software shut down, and I'm going to reboot it and get things going back here again. Okay, so I'll talk a bit louder now. I left tech support via text message. Alright, let's see if we can get the camera connected here again. Get things going back up here for you guys. Alright, we are once again live. Oh, I did not want to turn that on. I wanted to turn that off. Alright, we're back up again live. We'll go full screen here for a moment. Eclipse is well underway. Mid-eclipse, maximum eclipse, which is only going to be about 35–40%, is going to be at 3:28 p.m. my time here in Vegas. And I am going to jump out of here, try to take a couple of still images. I've got to reset all my settings again now. Alright, so we're going to take a still image here. Oh, skip. Okay, well that's good to know. Alright. I didn't know you guys had a friend who was a astronomy professor. You guys need to hook me up with him. Alright, we're gonna jump out of the still images and go back to the live view here. We are back live. I love this inverted image. I don't know why this view fascinates me. I guess it just because it makes the sunspots stand out so well. That's an inverted view of the sunspot there. Our good friend is also our personal I'm the astronomy professor. Huh, hardly. I just do this stuff for fun. You're so funny. Everything I learned just from fooling around with it in the backyard, not any official schooling. All right. Oh, I just bumped the microphone. Sorry about that, guys. So this is just going to be a partial eclipse. In fact, I don't think it's a total eclipse anywhere on the planet, unfortunately. There is a fantastic solar eclipse, total solar eclipse, coming up that I'm already planning on. And you're going to say, well, it's got to be nearby or near or soon if I'm already planning for it, right? No, it's August 21st of 2017. It's 1,032 days from now. I'm counting down the days. And it's going to be a total eclipse that's going to last a little over 3 minutes. Totality will last 3 minutes. Not going to be total here in Las Vegas. In fact, it's just going to be a partial eclipse here, but it's going to be close enough that it's a day's drive away. It's Idaho Falls, Idaho. is in direct line of the path of totality. The path of totality is only about, I think, 100, 150 miles wide. So you have to be in this little swath of land that's about 150 miles wide. It cuts across the United States in a kind of sort of a graceful arc, if you happen to be there. But Idaho Falls, Idaho happens to be right up I-15, so I'll be making a drive up there and spending a couple days up there to observe the total solar eclipse. It will actually be my first total solar eclipse. I've seen one annular, and I think this is my fourth or fifth partial eclipse. I'm going to go full screen here. You don't need to see all the other software information there. Get a better view. Hoping my good buddy Fred Bell and Glenn Petrachik can make that journey with me August 21st of 2017. It's going to be a long drive to get up there, but should be pretty cool. Unfortunately, I'll probably be in the boonies, so won't be able to broadcast it live. Plenty of pictures to follow in the days afterwards, though. Quiet crowd here. No questions? Come on, nobody's got a question for me? Come on, somebody play Stump the Astronomer. Try to give me an astronomically related question that I don't know the answer to. And I promise, if I don't know the answer, I will tell you I don't know the answer. I will not Google it offline on one of the other 3 computers that I have running here beside me. Just type your question for the amateur, and I'll see what I can do. I see my buddy Kevin is watching. I just saw your post. Looks like you're working today and doing a little covert solar eclipse viewing here. That's cool. All right, I am going to dump out of the full screen mode here, get back into imaging mode here, and take a couple of pictures. So we're in imaging mode there now. And it locked up again. Well, darn it. I am not happy about that. Huh. Alright, well, we'll go to our little animation here while I once again try to reboot this software. Kind of stinks that that it seems to be crashing every time I attempt to take a photograph as opposed to live view. The good thing is it did do a good crash that time, and it's rebooting fairly quickly here, so I should be back up and live here in a minute. And I think before I actually go live, I'm going to just fire off a couple of pictures before I bother to go live again. You guys can see what's happening here. I gotta reset all my camera settings every time it crashes on me. let's take a couple of images here. And the moon is a little off our view here, so we're going to move it over just a touch. I'll let it take about 3 or 4 pictures here, and then I will go back to the live view for you guys. So nobody has a question for Stump the Astronomer? Come on. Somebody's got to have a astronomically related question that they can throw at me. Shouldn't be too hard to stump me. Like I said, this is just a hobby. I'm not a professional at this. Going back into live view. Eclipse is well underway here. Let's take a good close-up look of that magnetic storm here on the sun. It's amazing the chaos that is happening right there in that storm. For anyone that's tuning in, this is a very large sunspot, which is basically just a magnetic storm on the surface of the sun. And the reason it appears black is because that area of the sun is about 5,000 degrees cooler in temperature than the surrounding area. So if you were actually able to isolate that black, just that black portion of the sunspot, it would in fact be incredibly bright. In fact, it would be blindingly bright, even a small little portion like that. But it all has to do with contrast and the fact that the sun around it is so much hotter. The hotter the areas, the brighter they are. So that's why a sunspot appears dark. It's actually not physically a black spot on the sun. It's just a much, much cooler spot on the sun. Alright, we'll get back out of close up there. Looks like our moon is just about to devour a little sunspot up in this area here. I always like watching that happen. Finally. Camilla, hey, how are you? You know, I never can remember. Are you in Florida or are you in Australia? I can't remember. Have you moved to Australia yet? Anyway, welcome, Camilla. Good to have you here. Eclipse is underway, as you see. You're watching a live view of the sun. I'll take it full screen here. Yes, I am. Somebody's asking if I'm... I am narrating. And of course, I realized as I was saying that if he doesn't have speakers hooked up, he couldn't hear me. So you're still in Florida. Okay, well... Okay. Are you, when are you getting... Oh, thank you. Yeah, that was pretty cool. I actually have another little animation thing that I created this morning because I took a close up of the sunspot yesterday, and I took a close up of it this morning, and using Photoshop I sort of overlapped them here, and so you can see a little bit of what's happening over the course of almost 24 hours as we bounce back and forth here between yesterday's image and this morning's image. I am going to shut the camera down for just a second and take a couple of images again. Hopefully the software doesn't crash like it has done a couple of times here. So if you don't have speakers, maybe if you have headphones, if you've got a headphone jack on your laptop or your PC or whatever, maybe you can tune in, you can hear if you want to listen to me talk. I'm still waiting on someone to give me the Stump the Astronomer question. I'm not a professional at this. I'm strictly amateur, so it shouldn't be too hard to stump me with some astronomically related question. And I promise not to Google if I don't know the answer. I'll just tell you I don't know the answer. Alright, that's enough images now of this. So we'll go back to our live view here in a second. Alright, we are back live at the sun here. Take it full screen for you guys. Okay. So let's see, what time do we have here? It's 2:36. We're about 25 minutes into the eclipse here. Mid-eclipse, maximum eclipse for us here in the Las Vegas area is 3:28 local time. That, Camilla, to answer your question, that sunspot is a magnetic storm. That's anytime you hear anything about solar flares or solar prominences on the sun, those are always created in sunspots like this, which is just a gigantic magnetic storm. It's similar to it's like worst case scenario for being on the surface of the sun, as if being anywhere on the surface of the sun would not be a horrible thing for us, but being inside a magnetic storm like this or a sunspot on the sun is even more terrifying. Imagine it just being like a hurricane or a typhoon here on Earth. It's worst case scenario, and there are constant it's basically a plus and negative pole that you see. That's why on most sunspots, not all, but on most sunspots, especially the bigger ones like this, you'll see what appear to be almost two distinct areas. And in fact, what I'll do is I'll zoom in on here and show you a little bit closer up image of this sunspot. So I'm not sure if you can see my cursor on the screen here, but I'm over like the main portion of the sunspot here. And over to the right here, you'll see another darker spot. The storms, the prominences actually just jump from one pole to the other on the storm here. And the solar flares are created inside these sunspots. And I don't know if it's erupting right this second. It could be. I'll go back to the full size image here. It could be. It wouldn't be a good thing for us because it's pointing directly at the Earth right now. Skip, how much of the sun is going to be in the shadow? I believe they said something like either 38 or 42% from our location here. Somewhere in that 40% range is going to be covered. It's it's going to just pretty much continue right along this path that it appears to be making right now. So it is just a partial. If we were further north, I believe somewhere up in Canada, about 80 or 85% of the sun is going to be covered. The one thing about the filter that we're using here is the filter that I'm using on the telescope is called a white light filter, because it's actually letting the same light that you or I see on the sun if we went outside right now, but it's only letting in like 0.001% of the light. So anytime you see images that show that real granular texture on the surface of the sun, and you see the solar flares and the prominences popping out along the edge, those are taken with a hydrogen alpha filter. It's a very narrow band filter that only lets a very small frequency of light through it, sort of like infrared or X-ray light. It's actually hydrogen alpha light, and it's a very narrow band, and that's the type of filter that's required in order to view the solar prominences as they flare up along the edge of the sun. They are visible one other time with the naked eye, and that's only during a total eclipse. You can't even see it during an annular eclipse. But during a total eclipse, there's a few brief minutes where if there happen to be any solar prominences erupting from the edge of the sun, then you can see them. But I don't really view the sun often enough to warrant the purchase of a hydrogen alpha filter, because from my telescope it requires actually two filters. It requires a pre-filter that goes over the front of the telescope, and then it requires a filter at the back end of the telescope as well, and it's about $2,000 for the filter. And you know, just for the occasional photograph, I just don't I just can't justify the cost, as much as I'd love to have one. But I can give you something that's kind of cool though. Let me back out of this full screen image and go into this HD mode. If I invert the image and I click on this Edge 1 button here, it actually does a really cool job of really highlighting the surface of the sun. I'm going to grab a screenshot of that because I like that. Let me save this real fast to my desktop, and then I will get back into the live view for you guys. Alright. I love that view of the sun. Back full screen and live. Inside cycling, right around 40% of the sun, 40% to answer your question, is going to be covered from my location here in Las Vegas. If you're seriously into solar eclipses and you want to see a total eclipse, August 20, and you're in the United States here, August 21st, 2017, it's right around the corner. It's only 1,032 days from now. There is going to be a total solar eclipse that's going to last a little over 3.5 minutes long. Total eclipse is only visible through a very, very narrow swatch of land, about 100 miles, 150 miles wide. You have to be literally inside the path. It's almost like being inside the path of a tornado. You can be 3 blocks from a tornado and your house stays standing, but if you're in the path, you get hammered. Well, a total solar eclipse is the same way, only the path is a bit wider than a tornado path. 3:28 local time here, Camilla, to answer your question. Well, you know, because of where you're at, East Coast, it may be past peak for you guys there. I've got another probably 45 minutes almost before peak eclipse here in Las Vegas. Anyway, getting back to that total eclipse, that little swath of land is going to pass right through Idaho Falls, Idaho, and that's where I plan on being on August 21st, 2017. It cuts actually right down through the heartland of the country, but Idaho Falls is an easy town for me to get to. Just hop on I-15 and drive almost due north from here, and I'll be there in, I don't know, 18 hours, something like that. I haven't actually looked into the driving time. So our eclipse is progressing pretty well here. I am going to once again bump out a live view here so I can grab a couple of still images. Reposition everything here. Telescope's drifting slightly. So I'm going to bump out a live view, take a couple of still images. I like to have some still images because I like to have something to be able to post online after the fact. If I'm just taking the live view directly out of the camera, then once the eclipse is over, I've got nothing to share with anyone. Alright, so I will abort and get out of imaging mode, go back into live view here once again. Luckily the software didn't crash on us that time. Great, great, great. Go back full screen for you guys. Any more questions? Feel free to type them in there in the chat window. I will try my best to answer. I have a question for everyone, since everyone seems to be too shy to ask me a question. The speed of light. How fast does light travel? Anybody know the answer? Come on, first one to post it wins a prize. I'm not sure what that prize is, though, because I have nothing for you. Just trying to keep you guys entertained here, because I know this is pretty boring for non-astronomy people that might happen to be tuned in. Tell you what I will do. I will make a composite desktop image for the first person with the correct answer. So you just tell me your desktop screen resolution, and I will make a composite of the still images that I take here for a very cool desktop image if you want it. Skip, that is not close enough. That's accurate, fairly accurate, pretty darn fast, yes. But not the correct answer, not what I'm looking for. I'll take it in miles or kilometers. Miles per hour or kilometers. And no Googling. Oh, you gave me meters? Come on, I don't know meters. I've got to convert meters to kilometers? Come on. Camilla, you would do that to me. I know it's about... Actually, no, you're correct. Camilla wins. It's 300,000 or it's 300,000 kilometers, so I guess that's 299 million meters. That's correct. All right, Camilla wins first prize. 186,000 miles per second. So traveling at 186,000 miles per second, light from the sun still takes about 8 minutes to reach the Earth. So if the sun were to go boom right now and just explode, we wouldn't know about it for 8 more minutes. Yeah, just remove 3 decimals. I know, I had to think about the whole, metric, meters, kilometers thing for a second there. Give me a break. I'm an American. We're stupid. We don't know, like, you know, uh, centimeters. We think of inches or miles instead of kilometers. So it's looking like that huge sunspot is not going to be covered by our partial eclipse today, which is kind of a bummer. I was hoping it would at least skirt closer to it. Um, yes, I am training my brain. I've got so much stuff going on right now. I've got 3 pieces of software running here that I'm trying to keep track of. I've got my main computer that's running those 3 pieces of software in order to get this live image out online. I've got my netbook on Facebook here, so if anybody chimes in on Facebook, I can kind of keep up with them. And then I've got my laptop right in front of me that is open to my Livestream feed that I'm logged in on, so that way I can actually see your chats because all of my screens are completely covered here. Um, yeah. So here's something you might not have known. Uh, it's estimated that the sun is about 4.5 billion years old. That's billion with a B, which is pretty average star life. But something that's interesting is that scientists and astronomers believe that the sun has already burned up about half of its store of hydrogen. So it's got about another 4.5, 5 billion years to go before the sun becomes probably, I'm thinking it's going to become a yellow giant or maybe a red giant as it starts to cool off and expand. When it starts burning up all of its fuel, it will actually start expanding in size, and it will expand larger than the orbit of Mercury, Venus, and potentially even Earth. So we'll be just absorbed into the sun as it expands. And I'm not sure if they think that the sun will eventually go nova or supernova. I'm not, I've never researched that. It takes a special kind of star, a certain size star that collapses in order to create a supernova, and I'm not sure if our sun is special enough for that. Either way, it wouldn't matter. None of us are going to be around to witness it. So I'm going to go back out of live view here again. Very carefully and slowly bump into imaging mode here. Try to take a few stills without the software crashing. Yes, you're correct, Camilla. We will have to send baby Kyle, Kyle L, or whatever his name was, Superman. I get the reference. Alright, so we're taking a couple of still images now that will begin popping up on the screen. I'll let it grab about 3 or 4 here. Then we'll go back to our live view. Alright, so let me jump out of imaging mode, get back into live view for you guys. We're back into live view. Go full screen again for you guys. So for those that are just tuning in, I originally early this afternoon I had someone ask me something about my telescope setup. I'll share that with you guys now. I am going to grab my webcam here, which I have on a USB extension cable, and let me switch over to the webcam. Webcam is F7 here. Alright, so there's the telescope outside my balcony door here. I know the image is kind of overexposed here. I don't know that these webcams are really designed for full tilt daylight. But as you can see, the camera is attached to the back of the telescope here. It's a Canon 5D Mark II. You can see I've got a USB cable there running into the house here, plugged into the computer, and that's how we're getting our live feed. Both the spotting scope and the front element of the telescope itself are covered with solar filters so that they can safely view the sun. And battery supply down there, and also you'll probably notice there's like actually a pillow sheet there that I've got taped. That's just blocking the sun from the console on the front of the telescope there, because I was a little worried about the heat today. I am glad though that this eclipse is in October and not August. Get my webcam set back up over here. So hopefully, again, while I was outside, I'm just kind of blindly pointing Camilla, I'm not sure what you're talking about there with the real-time magnetic activity. I've got a phone call coming in. Stand by 1 second. I'm going to mute. Telemarketers, you just have to love them. Not sure what you're talking about. If you have another tab available, you can see real-time magnetic activity here too. Is that a link to one of NASA's? I know the solar observatory. What do they call it? Solar Dynamic Observatory has some fantastic footage. I don't think it's real time though, live, but I don't know what Griffith Observatory is doing. Let me tune into Griffith Observatory and see what they're doing. Okay, here's the Griffith Observatory feed. Wow, they've got a great image. A little sharper than mine. I think they've got a little more money in their system too than me. I've got about 3,500, $4,000 tied up in mine. Nice feed though. Yeah, for some reason the live stream they won't let in the chat window they won't let you post hyperlinks to websites. Just tell me the name of the website without the www dot and all that mess, and I'll see if I can find it. All right, we are going to get out of live view once again. It is coming up on 3 p.m., about 28 minutes from maximum. I'm going to dump out of live view mode here. Capture a few stills. Oh, Soho. Yeah. Is it Soho or Slew? Well, I'll type in what you have here, Soho, and see if I can find it while the telescope is running on a couple of stills here. See if I can find. Oh, the Solar and Heliospheric Observatory. Aha, yes. The sun right now. Very cool. Very cool. Yeah, there's some great images there. I was looking at that website a couple of days ago when I was gathering all my little tidbits of information here. Alright, let's go back into live view on our camera. Let's get out of... I am, once again, I love this view of the sun, inverted with edge detail turned on. I'm going to do a screen capture of that. Sorry you guys have to see my my little random file savings and everything here. I've got to catch this stuff live though. Alright, we're back to our normal live view image of the sun. We'll go full screen with that. Alright, let me see if this is the same thing I was just looking at. Well, I am not seeing what you're seeing there, Camilla. nascom.nasa.gov/data. I copied all that and I deleted the spaces, and it's saying that that link is not a real link. But anyway, I've got my hands full with this stuff. I will try to track down some of the my buddy Kevin Smith is actually, I don't know where you're at, Kevin, but Get my live feed off of those screens. My buddy Kevin just posted a picture. He's projecting my live feed of the satellite into whatever this meeting is that he's working. Unfortunately, I don't think the rest of my Facebook friends can see it just yet because I've got timeline review thing turned on. So let me log into my Facebook and see if I can turn that on so everyone can see it. All right. Well, I don't know how many viewers you have, Kevin, in your room, but that probably just upped my number from the 16 that I've got online here. Inside Cycling TV. Oh, is that you, Kevin? I didn't know your it makes sense now. I didn't know your username here on Livestream. Okay. Do you have sound in the room too, or is it just the video? Great. Okay. Well, hello, Phoenix. Hello, people at the talking stick. That's cool. Just video. Oh, okay. Good. No sound. I'm already paranoid about my voice. Okay, cool. Well, all right. I'm glad it's not like during walk-in or anything that you have this up. It's during a room turn. That's cool. 3:06 p.m. We are about 21 minutes away from 22 minutes away from mid-eclipse. And just for those that are tuning in, very near the end of this eclipse, the eclipse is scheduled to end at 4:41, probably at about 4:15, 4:20, you're going to notice some very odd looking shadows crossing the moon, and that is unfortunately the power lines outside my house. The sun is going to be going down behind the power lines. They're not going to be sharp shadows though, because the camera and the telescope is focused on the sun, and they're very much closer in the foreground here, so they're going to be very blurry. It's 4:20. Yes, 4:20. Look for the power lines. Yeah, the pinhole trick. Yeah, I wonder if anyone else has done that. Yeah, just take a cardboard box or a piece of cardboard or really anything, um, and punch a very tiny hole in it, and then walk outside and hold the paper perpendicular to the sun so that the sun is hitting the sheet directly, and look down at the ground at the shadow that is cast, or the shadow that's cast by that tiny little pinhole, and it should be in the perfect shape of the eclipse. Easy trick for anybody to do. All right, Camilla, I'm going to give your link one more try here, uh, and see what happens. All right. Oh man, I've got spaces everywhere I've got to take out here. I know. They're pretty crazy about not wanting hyperlinks posted in the chat. I guess it's because it's for safety to keep people from potentially linking to viruses or something. All right. Well, it's still saying that link is not available, not found. Well, I'll go to the Soho NASCOM and try to find it that way. I'll just go directly to Soho NASA and see what comes up. Real-time images. Ah, there we go. I found the images you're talking about. Very cool. Yeah, it's interesting. Their normal white light image doesn't really look any better than my feed. I'm impressed. But they do have some awesome hydrogen alpha images and also some calcium lights and all kinds of different types of wavelengths in there to look at. All right. One more time. Time to do a little imaging here. Take 4 or 5 pictures before we continue on with our live feed. Anybody want to take a gander at the temperature of the surface of the sun? If you were literally standing on the surface of the sun, it would be a very warm day. I'll just give you that hint. And unfortunately, the notes that I have are in Celsius. Yeah, pretty darn hot. Skip, you are a man of few words, or I don't know if that's actually Joan chiming in there, but you're both correct. It's pretty darn hot. Let's go back live. (5,500 degrees Celsius). That is the average temperature on the surface of the sun. 5,500 degrees Celsius. Is that 9,941 degrees Fahrenheit? Thank you for the conversion there, Camilla. Okay, so that's the temperature of the surface. How hot do you think it is at the core, at the very center of the sun? And again, since I gave it to you, the surface temperature in Celsius, I'm going to give you the core temperature in Celsius as well. I guess I should ask, do you think it's cooler at the center or do you think it's warmer at the center? You know what would be really cool right now? I am so close to the McCarran Airport flight line. It would be really cool if we were able to capture a jet flying through. There's no way I could grab a still image of it though because it's just running live right now. Yes, my wife says the surface temperature of 9,941 degrees is the same as her having one of her hot flashes. Yeah. I am so glad I don't have to go through that. Oh, my buddy Glenn is posting pictures online. Obviously not Glenn, for anybody that knows Glenn, but his girlfriend Alicia is posting pictures. They're at their backyard observing the sun right now as well. Okay, drum roll for the core temperature. Actually, I think the core temperature of the sun is probably closer to the temperature of my wife's hot flashes. 15 million degrees. 15 million degrees Celsius. That's what the estimated temperature is at the core of the sun. So mid-eclipse once again is at 329. It's about 314 right now. The diameter of the sun is about 1.3 million kilometers in diameter. 1.39, I believe. You could fit, if you took the globe of the sun and you took the Earth and you kept the Earth as a globe, you could fit about 960,000 Earths inside the sun. Imagine the sun, imagine a jelly bean jar the size of the sun, and imagine the Earth is jelly beans. You could fit 960,000 of them inside the sun. And actually, if you don't care about the shape and you want to just cram them in there to get as much and just flatten and smash them out, just actual mass, you could get about 1.3 million Earths inside the sun, which is pretty crazy. Pretty crazy. And the sun is just an average star. There's nothing really special about it. There are a lot of stars out there that are much smaller and much cooler, and there are tons and tons and tons of billions and billions, as Carl Sagan would say, although he never actually said that. There are billions of suns out there that are much larger than the sun and much hotter. See, the only reason I knew that answer, Camilla, is because I did my reading beforehand. I knew I was potentially going to have people asking me questions, and so I did a little studying this morning and last night. Otherwise, it would have been one of those bits of information that I probably knew at one point in time, but did not remember. So Kevin, to answer your question, it's a question I actually mentioned earlier. You might have been working and not able to hear, or you may not have tuned in yet, but they estimate that the sun is currently about 4.5 billion years old, plus or minus a little bit. And they also estimate that the sun has burned up roughly half of its hydrogen. So they think that the sun will actually die out in another 4.5 billion years, as Camilla has answered you in the text message here. So it's not a really concern for us, I don't think, unless you plan on somehow escaping the inevitable. 4.5 billion years, give or take a billion or so, I guess. The sun is considered a yellow dwarf star because it is actually, I said average, but it's actually a little below average size star. Alright, I'm going to jump out of live view here once again. We're coming up on, well, we still got about, I'll take a series of images now and then again at 3:29 local time during maximum eclipse. Trying to remember to take photos every 10 minutes or so. Here's another interesting tidbit for you. The sun, from all the measurements that have been done, is almost a perfect sphere. Even the Earth and all of the planets are kind of squished, kind of egg-like, but the sun is actually within 10 kilometers difference from the poles to the equator of being a perfect sphere, and it's actually considered to be the closest thing to a perfect sphere that's ever been observed in nature. So that's pretty cool, within 10 kilometers if you consider the size, the overall size of the sun. That's pretty amazing. Anybody have an idea how fast the sun is moving? As you know, we're rotating around the sun in orbit. It takes us 365 days to travel around the sun one time. But the sun is just one tiny little star in the Milky Way galaxy. And it's also rotating in one of the arms of the Milky Way galaxy around the center of the Milky Way. And it's moving at 220 kilometers per second. I believe you are correct, Kevin, that it does have something to do with the mass and the gravity that keeps it spherical. But, you know, I mean, the planets are the same way. Actually, Jupiter, when you're looking at Jupiter, Jupiter is a gaseous planet. And but Jupiter is quite obviously like bulges at the equator points. It's much further around the equator than it is around the poles. It's got a very squatty look to it. You may not have ever noticed it, but if you pull up a picture online of Jupiter, you'll probably see that it's not a perfectly round circle. And Saturn and the rest of the planets are the same way. The Earth is squished too as it's being pulled gravitationally by the moon. It's a little further around the equator than it is around the poles. So even though the sun is moving at a little over 200 kilometers per second, it still takes between 225 million and 250 million years for it to orbit the Milky Way galaxy one time. So that's kind of cool. Another tidbit there. Let me reposition our sun here. It's drifting off a little bit to the left. I'm going to stay in live view here right up until you're right, Camilla. That is from now on, that is your excuse for having a bad hair day. The sun. It's the sun's fault. It's pulling us along the galaxy at 200 kilometers per second. That's something that kind of freaks people out when you ask somebody that's standing still, how fast are you moving? And I forget what the actual number is, but it's something ridiculous because first of all, the Earth is spinning on its axis, so that's one motion that it's moving. Secondly, the Earth is orbiting the sun, so we've got movement around the sun taking 365 days to go around once, so that's a second angle of motion. Then you have the sun itself moving in the arm of the Milky Way galaxy, so that's like sort of a third motion. I think when you combine those, we're moving at something like, I don't know, something ridiculous, like 20,000 miles per hour or something through space. We're traveling. Kind of mind-blowing. going to grab one more shot of this. I love this view of the sun. Back to our live view again. Full screen here for you folks. Coming up very close to mid-eclipse here. We've got about 4 minutes away, 3 minutes away. So does anybody want to take a guess at what the distance from the sun to the earth is called in astronomical terms? You know, like we have a light year, which is the distance that light travels in 1 year, which I think is something like 4.5 trillion miles. But there's also an astronomical term for the average distance from the sun to the earth. No Googling, just guess if you know. If you don't know, then just take a guess. It's actually a unit of measurement that you might have heard of, and it's usually used to measure distances in our solar system only. Outside of our solar system, it's a fairly small number. You are correct. Ooh, Camilla, you're like on the A game today. It's considered 1 astronomical unit. It's the average distance is 149 million miles, a little over 149 million miles, and that's considered 1 astronomical unit, and it's a unit of measurement to measure distances between the planets and stuff like that. So like the distance from the Earth to Jupiter is about 5.2 astronomical units. All the way out to Pluto is 39 astronomical units. And once you start getting out of the solar system and you start talking about distances to stars, then that's when an astronomical unit is not a very good number to use, because it starts getting outrageously large, and that's when they start using light years. Because it's, okay, so Miss Smarty Pants Camilla, you knew the answer of 1 astronomical unit. So your book addiction pays off, yes. So what is the distance to the nearest star? Of course, I have no way of knowing whether you're Googling this in the background, of course. So I'm taking you at your word. And the distance would be in light years. All right, I've got an alarm going off, which tells me we're 1 minute away from mid-eclipse. So nearest star in light years. That would be if you could travel at 186,000 miles per second, which is the speed of light. This is how long it would take you to get to the nearest star. Oh, you're way off. Way off. Much closer than that, believe it or not. Camilla got one wrong. Camilla got one wrong. I'll tell you what star it is. I'll give you a hint. I know you've heard the name because it's a very popular named star that always comes up, especially in science fiction. It's Alpha Centauri. Alpha Centauri is the name of the star. Alright, I am going to get out of live view here since we are at mid-eclipse. You're correct, 4 point something. It's about 4.5 light years away. 4.5 light years to Alpha Centauri. So if you could travel, just to get your head around this figure, if you could travel at 186,000 miles per second, it would take you about 4.5 light years to get there, 4.5 years to get there, traveling at the speed of light. It's kind of weird. A light year is actually not a, obviously it's not a definition of time, it's a definition of distance. David, you're on the wrong chat screen now, David. Please sign out and log into whocaresaboutfootball.com. My buddy David from New Orleans, or from Alexandria, I should say. How are you, buddy? So right now we're looking at a still image that I just took of the sun, and I am going to go back into live view mode here. And we're now looking live at the moon. Or, I'm sorry, we're looking live at the sun. Yes, it is definitely more than a weekend trip. Yep, it's all downhill from here, Camilla. Same thing you've been watching for the last couple of hours in reverse now, unfortunately. We're at mid-eclipse. Are you, you're in Florida, so I'm kind of losing track of what time it is. Is it dark there? Has the sun set? If the sun is very close to the horizon and you've got some dark sunglasses or something, you could, I wouldn't say safely look at the sun, but you could probably take a peek at it, especially if there's a lot of haze on the horizon. Yeah, David, I'm glad you joined in. I've got a whopping total of 26 watchers right now tuned in to my eclipse. I haven't even tuned in yet to the Griffith Observatory to see how many they've got, but it's usually in the thousands. I'm going to hop over to them for a second and see what their feed looks like. Let's see. Oh yeah, they've got a whopping 30,250 viewers at the moment watching their feed. So none of you leave my feed here because I need all the viewers I can get. I've got to try to put the Griffith Observatory out of business. Yeah, my 26 viewers. I got to figure out how to promote stuff like this. You know, I just posted on Facebook. A few friends watch it. Unfortunately, you have to log in. You have to log in order to view this. The eclipse that I did back in April, I used UStream instead of Livestream, which didn't require you to actually sign up and log in. So I had a lot more viewers for the lunar eclipse. But anyway, still cool here for those that have taken the trouble to sign in and join me. No, Adriana, I am not an astronomer. I'm a photographer and a union stagehand. This is just a hobby for me. I've got a 12-inch Meade telescope and a Canon 5D camera that's hooked up to it that's feeding everything live to us. In fact, I will tell you what I will do in case I've got a few new viewers right now. I'm going to dump out of the live view here and take a couple of photographs. Let me get this going, and then I will show you my setup here. I've got three software programs running in order to be able to switch inputs and switch feeds. You're looking at a direct feed from the camera right now going into a software program called Backyard EOS. And I have my desk set up here right by my balcony. And outside on my balcony is the telescope. So let me see. I need to switch over to the live webcam, which is input 7 here. So, all right. It's a little bright outside, but this is looking outside my balcony door. You can see my camera and my telescope set up. And I've got the system running a series of photographs right now, so it's taking a picture about every 10 seconds, I believe. And that's pretty much it. The camera is very overexposed because it's so bright outside, and I don't think these webcams are actually designed for indoor or for outdoor use like this. And I'll go back to our live feed here. Yes, Adriana, those are sunspots. Those are huge magnetic storms that are actually on the surface of the sun. They appear black. In reality, though, they're very bright. They just happen to be about 5,000 degrees cooler than the surrounding area. And so if you could isolate that black spot, here's what I'll do. Is I'm going to get out of imaging mode here and go back into live view. And I will show you a close-up of that sunspot. So let me turn my targeting back on here. And then we'll go into magnified mode here. So that is the equivalent of a hurricane or a typhoon on the planet Earth. That is a magnetic storm on the surface of the sun. This is where all of the really bad stuff on the sun happens. If you ever hear in the news about solar flares or knocking out power lines or knocking out power stations, happened a few years back in Canada, a really bad power outage caused by a magnetic storm on the sun. Also, one of the reasons that we have the aurora that's visible here on Earth is because of the gigantic flares and prominences that flare up on the surface here, and they're all centered or all caused by these gigantic storms that are on the surface of the sun. Again, you're looking at a close-up of it here, and although it looks black, it's actually very bright. It's just the contrast is so much different. It's about 5,000 degrees cooler than the surrounding area. So yeah, meteors, comets, everything crashes into the sun. The sun's got a huge gravitational pull on everything. It's actually what's keeping us flying around safely in orbit. So almost every day there's stuff that crashes into the sun. Charles, I see Nikon with a question mark, and the answer is no. It's a Canon 5D Mark II is the camera that I'm hooked up with the software here. We'll go back to our full screen view. So we had a viewer earlier from the UK. I know Camilla is in Florida, David is in Louisiana, Charles and Adriana. I don't know where you guys are from, so chime in with the chat here. Tell me what part of the world you live in. I think our visitor from the UK might win the award for longest distance viewer. I don't know how that would be possible, Adriana. Once it crashes into the sun, I'm sure actually even before it reaches the surface of the sun, it is probably completely destroyed by the intense heat and gravitational pull. So, sounds like a little bit of science fiction. Ah, Lynn's in Atlanta. Welcome, Atlanta. Very cool. Sun's going down over there. Adriana's in Denver. Nice. Uh, yeah, the sun is really bright out here in the desert, Charles. Let's see, our image is drifting a little bit here. Let me get it back centered over here for you guys. Charles, I wouldn't recommend it. Adriana, I'm in Henderson, which is a suburb of or a city just outside of Las Vegas, Nevada. And Charles, as far as the dark sunglasses, you know, if the sun is close to the horizon and you're shooting and you're viewing through a lot of atmosphere and maybe it's a little bit of haze or clouds or whatever, and you have dark sunglasses, I can't honestly recommend that you go outside and just look at the sun with dark sunglasses. I can tell you one thing though, if you look up at the sun and your eyes start hurting, even with the sunglasses on, you're doing damage to your eyes. Uh, so pain equals damage. So if you can, with sunglasses, somehow look at the sun again, I really don't want to go there because uh, the professionals won't recommend that. Um, if you had a welder's glass, which I know most people don't have, Adriana, I don't think there's any such thing as a meteor the size of Saturn. Saturn is huge. Saturn is the second largest planet in our solar system, and it's uh, it's pretty giant. So there wouldn't be a meteor anywhere near the size of Saturn. Well, again, Charles, with the digital SLR, I had a friend chime in yesterday telling me that she used live view on her camera to to view the sun. I would never, without a solar filter on the front of my camera, I would never point my camera even using live view at the sun, because what the camera is going to do is automatically going to put it at 1/8,000th of a second, and it's going to stop down your aperture to f22 or whatever the lowest aperture is. Even with those settings there, you still got way more sun coming in than your sensor can safely handle. Um, so it's not something I would recommend. Sorry, I've got it. I've got text messages and everything coming in now. Uh, trying to manage everything that I've got going on here. Yeah, Adriana, I don't know where you mentioned why is the moon not always full? Well, because the moon is orbiting around the Earth, and so sometimes the moon, like right now, is a new moon, and the reason is because the opposite side of the moon is lit up. That's the side that's between the moon and the sun. In a couple of days, if you look towards the west, you'll see a very thin, waning crescent moon start in the sky until it becomes what some people call a half moon. That's actually not a half moon. It's considered a first quarter moon because the moon goes through four phases. It goes through new moon, which is what we're experiencing right now with the solar eclipse, and then the first quarter moon, which is when it looks like a half a moon, and then you have a full moon, and then you have the opposite of the first quarter moon. You have a third quarter moon when the moon is waning towards becoming a new moon again. So that's sort of your three phases. If you if you go online and you search for phases of the moon, you will almost surely come up with like a little graphic that shows how the moon is orbiting the Earth and in relation to the sun, and shows you what the phases look like. I can remember when I was a kid in school, my science teacher actually turned out the lights in the room and he used a globe. He used a person sitting in the center as the Earth, and then they took a light shining from one end of the room, a very bright spotlight type light, uh, and then they had a person walk around that person holding a globe, and the person with light was shining on the light constantly. And as you followed the moon in a circular path around you, you could actually see that globe go through the same phases as that the moon goes through. I didn't hear about a solar flare that knocked out power in Denver yesterday. Um, I did, I mean, it has happened before. There have been solar flares that have caused power disruptions, here on Earth, but I didn't hear in the news about one that was happening yesterday. And I've been online doing nothing but astronomy related stuff the last couple of days. I think I would have probably ran across an article or something about that. I'm going to drop out of live view here and snap a few images while we've got some time. I think the most famous power outage caused by a solar flare was several years back, and it was up in the northeast, up into Canada, Montreal area. There were some severe power outages out there that was caused by a solar flare. Hey, the Griffith Observatory is down to 29,000 viewers, and I'm up to 26. Woohoo! That's good news, Charles. Thanks for the update. Maybe by the end of this eclipse, I'll have 30 and they'll have 25,000. Who knows? So I do have a photograph. I'm going to imagine that we've got some, actually, this little animation right here that I'll share with you that kind of shows the what's happening here. You can see the time up in the top of the graphic there. It shows the beginning of the eclipse. That's right, David. I'm eating away at that 30,000 number that the Griffith Observatory had. Before you know it, everybody's going to be watching me. But this little animation just kind of shows the path that the moon is going to take here. Well, Adriana, you're in Denver, so was the news reporting anything that it was caused by a solar flare? Like I said, I didn't hear anything about that. I've also got a picture here that shows sort of my telescope setup. This kind of shows the front end of the telescope a little better. This is not a live image or anything, obviously, because I'm here on my balcony. But it does show the front end of the telescope, and it shows the solar filter that's attached. Again, the only way to safely observe the sun is with a solar filter that's over the front end of the lens. And you can kind of see it looks like it's white, but there's also like a silver disc in the center there. That silver disc is actually the only portion that is a solar filter that is letting light through. The white portion of the filter covering the lens is just a solid plastic type material that's completely blocking the sun, because with the solar filter that's on there, it's letting in about, I think, 1/1000th of a percent of the sunlight. And we are looking at the natural light color of the sun. They do make different filters that will allow you to see different wavelengths of light. I know SOHO, which is the Solar Observation Heliosphere Observation, I think is what it's called, has several different wavelengths of light that will show a lot more detail on the surface of the sun. Let's go back to our live view now. We'll go back into live view mode. Well, there we go. Got to see me for a brief second there. Oh, no need for that mess. The texts actually come through. I'm not real sure. Maybe we could do a test. I don't know how long the text message goes through, how long it takes. I can start counting, and let's say on 5 just send something, and I'll tell you when it pops up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, I'm going to stop counting because I just realized there's about a 20 or 30 second delay on my feed. But what I can do is I can chime in on the chat. What I will do is I'll get ready. All right, I just saw your test, David, and you're not going to hear me say that probably for a little bit. Well, the moon controls tides, so it does control the tides. The gravitational pull of the moon as it orbits the Earth controls whether we have a low tide or a high tide. Low tide is always the opposite side that the moon is on. Yeah, Camilla, that's something that I realize. I actually have the live feed that I'm watching here on a laptop next to my computer, and I had to turn the sound down because I knew there was about a 20 to 30 second delay between the time that I say something and the time that anybody else online hears it. And it's different also depending, I guess, on the internet connection, because the feed is going to the live stream folks and then they're broadcasting it out to you guys. And so depending on your download speed, there could be a bit of a delay there too. My wife was sitting next to me the other day watching the live stream on her cell phone, and it was about a 20-25 second delay between the time that I said something and the time that the sound came out on her cell phone. So anyway, what are the questions out there? I know there might be a few new viewers, so because we're up to a whopping 27 right now, so I am going to kind of jump in and zoom in on this magnetic storm here so you guys can see it up close. Well, it controls the tides because the gravitational pull of the moon is actually just basically trying to yank everything off the Earth and pull it towards the moon. And so the moon, it controls the level of the tides. If you've ever been on the ocean or a beach somewhere and been there during low tide and high tide and seen the difference, wherever there's a low tide on the opposite side of the planet, there's a high tide, and vice versa. So that's about really the only control that it has over the water. And it takes a large area of water too, like an ocean. Like, I don't think it does anything to lakes or streams or a glass of water or anything like that. I am going to jump out of this for a second and turn that invert mode on. So this is just a inverted view image close-up of the sunspot. I'm great, Ethan. How are you? What part of the world are you in? I'll go back to our live view mode. Get out of the... We're sitting here watching the solar eclipse. We just passed mid-eclipse a few minutes ago. We're on our way to the end. And for those that are just tuning in, probably in the next 15-20 minutes or so, you might see some strange faint shadows crossing over the image here. What that is just outside of my house I've got some power lines, and the sun is going to pass down behind those power lines, so we're going to see a little bit of a silhouette of the power lines. Fortunately it's not too bad. They're obviously way out of focus because the telescope is focused on the sun, so they'll be very blurry. Yeah, David, I like that inversion view too. I've taken several snapshots today of that image off my computer screen because I think it's just like a really cool look. Something that this software allows you to do. It's actually really good for focusing. When you turn that edge view on, it creates a very sharp edge on anything that is sharply in focus. And so when you are adjusting the camera focus or the telescope focus, it really pops into view when things are in perfect focus. So this is a still image now, and I believe it will update. I'm taking a picture. Yeah, it's updating. It's taking a picture about every 10 seconds rather than the live view. I'll go back to live view here in a second. I just wanted to make sure I actually grabbed a couple of stills at this phase of the eclipse. Thanks, Adriana. I've been called something besides just smart, but not smart. This is just a hobby for me. I just love doing this. I love sharing the sky with people. Going to try to do this more often when there's activity. Unfortunately, you know, in the nighttime, the images, the stuff that we're looking at are so faint that it's really hard to see, other than the moon. So it's not that great a view to try to stream something live like the planets or any of the nebulas or galaxies. The galaxies are completely invisible in the camera view mode like this, especially the fainter stuff that's up in the sky from this location in the middle of downtown Henderson, or near downtown Henderson, near Las Vegas. The night sky is pretty blown out here. Not a lot of great views. But for something like this, or for a lunar eclipse, it's fantastic. Going to take one more picture here and then we'll shut it down and go back over to live view. All right. Back into that crazy inversion look with the edge turned on. You can really see. Let me highlight this sunspot, zoom in on it. David, we're actually like almost at maximum right now in the sunspot cycle. I think we're about a year away of the 11-year cycle that the sun goes through between maximum and minimum. And I can't remember honestly if we're a year before maximum or if we're a year past maximum, but we're very close to the peak. That's a great view of that sunspot. Let's go back out to our full image. That is a pretty crazy view, isn't it? Really got good focus too. That bubbling that you see is a combination of the surface of the sun itself bubbling, but more likely it's the atmosphere between in the sky here, the heat rising up off the rocks and the rooftops and everything. So when you do a very highly magnified view like that, you get a little bit of motion, a little bit of bubbling in the image, and that's what you're looking at there. And it's October too. The temperatures are actually very nice outside. In fact, it's showing that it's 86 degrees outside. If we were doing this in July here in Las Vegas, temperature outside would probably be about 110, 112, and it would be just a blurry, bubbling mess. So actually a good time of year for Vegas anyway, for the solar eclipse. We'll go back out to full view here. Go back full screen. I guess the other thing I could kind of see if I can show you is, let me go into a magnified view of right around the edge of the sun, or the edge of the silhouette of the moon here, because as we all know, the moon is covered with craters and mountains just like the Earth is. So you'll notice that it's not a perfectly round image, and I don't know how much of that is just the distortion in the atmosphere, but under some seriously high-powered telescopes with really good viewing, you can actually see the outline, the silhouette of the mountains and the craters on the moon. I don't think that's what we're seeing here. I think most of this is simply I'm going to pan around the edge of the moon here. I think most of this is just the atmosphere, the turbulence in the atmosphere. Yeah, I'm not really seeing anything there. We'll go back to our full image here. Get the moon back in our view, or the sun, I should say. Thanks for tuning in, David. Glad to see a Louisiana boy tune in here. I don't think my family or anyone else is tuned in. I sent my parents an email, but I'm just lucky if my dad can actually get the email, much less figure out how to follow a link and log into the website here. Looking at the sun live, we are time-wise, we're about 40 minutes away from the end of the eclipse. 40 minutes away from the end. Not quite. Sun is not quite in the power lines yet, so we still don't have any shadows. I think those are probably going to hit our view about 4:15, 4:20. We'll be picking up a little bit of fuzzy, shadowy area going across the surface of the moon. I did have something while I was doing my test images yesterday, testing the software and everything to make sure it all worked. There was an airplane that did not pass through the view, but it passed very near the view, just outside the field of view of the sun. And the contrails that the plane left drifted across the image of the sun. So that was kind of cool. And it happened so fast I wasn't able to grab a still image of it, unfortunately. But that was a very cool sight to see. I was kind of thinking, because of the time of day, with the position of the sun in the sky from my house here, I'm very close to the flight line of McCarran Airport, one of the busiest airports in the country here. So we might get lucky, and if you don't blink when it happens, might have a jet coming into McCarran Airport here pass right through our view. That would be really cool to watch. It's all just pure luck, though. Hey, Craig. Cool. Thank you. Yep, we're watching the sun live here. We've just passed mid-eclipse. Mid-eclipse happened at about 3:28 p.m. local time. Scheduled to end at 4:41. Just a partial eclipse. Fantastic magnetic storm there with that gigantic sunspot. The sun just skirted by it. But I don't know if you guys have just tuned in or if you've been watching, but I can actually zoom in on that sunspot so you can really get a good look of what it looks like. This is a very large sunspot on the sun, and even though it looks black, it's actually very, very bright. It's about 5,000 degrees cooler than the surrounding area, and so it appears black just because of the contrast of the temperatures of the two areas. And this is where all the chaos on the sun that we experience here on Earth is caused from. Auroras, which are beautiful to look at, but the magnetic storms also cause power outages here on Earth with these solar prominences and solar flares that flare up from these magnetic storms. You'll notice there's seems to be like two distinct dark spots, a larger one on the left there and a smaller one on the right. And you have sort of like a plus and minus negative poles there, and these flares jump from these poles. And that's what causes power outages, satellite communication disturbances. A lot of problems are caused by something as seemingly innocent as that little sunspot right there. So we'll go back to our full screen view of the entire sun. All right, Lynn. Thanks for tuning in. I'm dropping members. Oh no! What am I gonna do? I'm gonna stick with it. I'm curious though to see about the Griffith Observatory, to see where their numbers are setting right now. I'm down to 21 viewers. Thanks for tuning in, Lynn. Glad to have you. Gonna switch over to the Griffith feed here and see. Oh, they're down to only 23,000 viewers. They were at 32,000 earlier today. I guess people are getting bored with them as well. So a mere 23,000 viewers watching the Griffith Observatory feed. Yes, Camilla, we've already determined that your bad hair days are caused by, oh well, they're just caused by the sun in general, right? Sunspots are pretty ugly little things, even though they're very cool to watch. I do have a little animation here for any new viewers that other people have already seen. I'll switch over to this right now. This is a picture that was taken between yesterday around 2:39 in the afternoon and this morning at 11:53, and you can see a little bit of difference in the shape of the sunspot. I tried my best to do a little manual alignment between these two images in Photoshop before I created the animation, but there's definitely a little change in its shape. It'll change constantly. It may get a little bigger than it is even now, and it may be at its maximum size right now. It may be on its way to dying out. I'm not real sure because I haven't since the last couple of days. I haven't really been following the sun too closely. Oh, that's right. Your bad hair days are caused by the solar and planetary movements. Ah, yes, I remember. Yes. Well, let's see. I'm going to go back over to I'm going to switch back over to our image here of the sun, our current image of the sun. You're actually looking at a still image that's being updated about every 10 seconds at the moment. It's not in live view at the moment. I will bounce out of this though and get us back into live view here in a second. Hopefully the software doesn't crash on me. No, we're holding steady. That's good. All right, we're back in live view mode again, folks. Go full screen with that for you. Well, I don't feel bad about losing a few of my viewers because the Griffith Observatory has lost about 4,000 of their viewers, 5,000, oh, more than that. They went from 32,000 down to 23,000, so they've lost about 9,000 viewers. So my 2 or 3 people that have dropped off and can't hang for another 30 minutes, I don't feel too bad about losing those guys. If anybody has any questions, now's the time. Eclipse is scheduled to end at 4:41, so I'll probably be online till about 4:45, and then we'll be signing off for the day. We've been online now for about 2.5 hours since the beginning. I've got trivia questions. Anybody want a trivia question? See who can come up with the right answer out there. What type of star is our sun? That's our first trivia question for the day. What type of star is our sun? There's certain types of classifications for stars, and our sun is an average star, but there's an actual technical name for it. I'm pretty impressed with the live stream. I'm pretty happy with this live feed though. It's gone really well. The live stream software has worked great. The software that I'm using to allow me to switch between all these inputs, that is you know, add my camera in here like this, which is tilted up a little bit. I'll tilt that down. You can see my ugly mug. So, and then this graphic here that shows the timings. These are all inputs on a little software switcher program that's called XSplit, XSPLIT Broadcaster. It actually gives you with a subscription, which is not that much. I think it's $30 for 90 days. It gives you 12 inputs. I'm using about 5 or 6 of them. Got a great photograph here of my telescope that was taken during the during the May eclipse. My baby dog just walked in. That must mean Mama's home too. Hello, baby. You want to say hello to people? I'll show you my baby dog. Watch out. Where are you going? Oh, she doesn't want to play. Now she left and went in the other room. Come here, Bella. Come here, Bella. Well, Camilla, it's actually it's a G-type star, but there's like a common name for it. I'll just tell you, it's called a yellow dwarf. It's called a dwarf because it actually is on the smaller size of stars. I'll show you my baby. Where's my baby? There you are. Where are you going? Huh? Oh. You gonna bark? Really? Really? You gonna bark? Okay. Alright. She's like me. She doesn't like to be on camera. Stop. Stop barking. Thank you. Yes, they're hearing you. Everybody in the world that's watching. Hey. Yes, my lovely dog. She does not like cameras. Miss Joni and Skip are saying hello to you. Not that you care. Badness. Yeah. Everybody's saying hello to you, and you're being mean and barking at everyone. Alright, I am going to do this edge-on shot of the sun here, this inverted edge color, because I want to grab one more image of that. I'll probably try to grab another one too before the eclipse ends. Let me save this real quick to my desktop, and then we'll get back to all the fun. And we're back to our live view now. Yes, my baby dog went to the vet today. She has a little problem with her back left leg. She's been favoring the right back leg lately, kind of lifting up on the left one like she's hurt, but we can't figure out what it is. So I'm kind of anxious to hear from my wife when she finally comes upstairs here in a few minutes to see if they took an x-ray, if they determine what the problem is with her leg. So Joan, the next astronomical event that you are most excited about. Well, you know, that's the thing about astronomical events. They're few and far between. Right off the top of my head, the next thing that I'm really excited about as far as like planning a location and everything is August. The Perseid meteor shower in August. I believe it's going to take place 1 or 2 days before or after a new moon, which means we're going to have very dark skies. So I'm hoping to have some very dark, clear skies for that. That's the next big thing. Probably the one big thing that's even bigger than that, that's much further away, unfortunately. August 21st, 2017, there's a total solar eclipse that I'm going to do a very long multi-day road trip for, because the total eclipse is only going to be visible in a very narrow swath of Earth, and the closest place is Idaho Falls, Idaho. So I'm going to be driving up there most likely with Fred Bell and Glenn P. And we are going to be camping out somewhere to watch that solar eclipse. Very exciting. I've never actually witnessed a solar eclipse. I've witnessed an annular eclipse, a total solar eclipse, I should say. I've witnessed an annular eclipse May 20th of 2012 with Fred. And I've witnessed probably 4 or 5 partial eclipses, counting today's. But the total eclipse on August 21st, 2017, which is 1,032 days from now, that is what I'm the most excited about. But as far as short term goes, I like to try to get out anytime there's a new moon and I can get to dark skies. Only I don't like going out when it's super cold. So there is a event actually tomorrow night out at Ash Meadows. If you're familiar with where Ash Meadows is, Ash Meadows, if you drove out through Pahrump and then took a left, headed out towards Death Valley, about halfway between Pahrump and Death Valley, there's a nature conservation area out there called Ash Meadows. They're having an astronomical night tomorrow night. Not sure if I'm going to make it or not. I'm not working, so I really don't have much excuse. I should load everything up and head out there for that. So we've got that. I've got the Perseids next August, and then I've got August of 2017, the total solar eclipse from Idaho Falls, Idaho. So that should answer that question. I haven't even looked into when the next lunar eclipse or the next solar eclipse, partial solar eclipse is that's visible here from home that I would be able to broadcast. So you know what I'm going to be needing from you next August, right, Joni? I'm going to need to borrow your camera. I'm going to have my camera running with my 24mm lens. I'm going to get your camera, and I'm going to try to get my neighbor's camera. And I'm going to probably rent 2 more 24mm lenses so that I can cover a pretty wide area of sky for the Perseid meteor shower. I love the Perseid meteor showers, and I think I have found the location where I'm going to go to. My recent trip up to Zion, there's a campground called Lava Point Campground. It's outside of town, and some very high up, 7,800 feet. So even in August, it's probably going to be very cool there. It'll probably be in the 70s or, I don't know, maybe 80s. And it's some pretty dark skies, and I'm going to try to get as much coverage of the sky as I possibly can. Taking a few images right now. Go back into live view. Getting pretty close, guys. 4:40 is the end. So we've got about a little less than 20 minutes. 4:41 is the end. A little less than 20 minutes away until the end of the eclipse. It's 4:20 now. Should start seeing that funky little shadow of the power lines coming into our view probably in the next 5 minutes or so. It'll be an out of focus blurry line kind of just traveling from bottom to top of the image as the sun goes down. Are you able to explain how scientists are able to predict up tell the precise day and time when these different events will occur, especially when they are so far into the future? You know, that's a very good question. All right, Camilla, you're very welcome. Hooray for math and science. That's the answer, Skip. Math and science. Um, you know, I know how it's done now. There's so much software that is able to predict everything. How these geniuses back in the 1200s, the Chinese, you know, in 800 BC, were able to predict when there was going to be a lunar eclipse or a solar eclipse. Um, it's just, you know, night after night after night of observing and studying and note taking and b- being able to calculate uh, if you know where the sun was 2 days ago, or if you know where the moon was 2 days ago and you know where the moon was 1 day ago, then you can probably take a pretty educated guess as to where it's going to be today or tomorrow or the next day. And it's way over my head to answer your question as far as how they're able to do it. These geniuses like Isaac Newton and Galileo and Ptolemy, all of these Plato, all of these astronomers from the ancient times, the way they were able to calculate this stuff. You know, Halley's Comet was one of the first things that Edmund Halley, who was an amateur, or not an amateur, he was a professional astronomer. Um, he was able to predict the return of Halley's Comet in, I think, 1909, and he was able to predict it something like 50 years ahead of time. It's just, it's crazy. And he was able to do that from his own observations of the comet during his time, as well as uh, documentation of he was able to research in, I guess, these journals that astronomers have always kept of past uh, comets that have come through. And he noticed a pattern of something like, I think Halley's Comet comes through every 79 years, something like that. And he was noticing that every 79 years in these documents going back for hundreds or thousands of years, that there was a comet that would pass the Earth. And so that's how he was able to predict that all of these comets that were passing every 79 years were the same comet, and therefore able to predict the future. Uh, so does that long-winded answer your question at all? I know there's a lot more to it as far as predicting solar eclipses, but even the Mayans, I'm trying to remember the name of that. Um, it was a movie that was, I believe, directed by, oh God, now I can't think of his name. The guy from Lethal Weapon. It's had all kinds of problems. Anyway, he made this movie about the Mayans that had no English. It was all subtitled. Anybody want to chime in with the answer to this movie? I could go to Internet Movie Database. Um, somebody's going to chime in before I can even get to it and figure out the name of this movie. Mel Gibson. Yes, Mel Gibson. Okay, so Mel Gibson made this movie, and it was about the Mayans. So let me look up Mel Gibson here on Internet Movie Database, and I'm going to get you. It's actually a pretty cool movie. I didn't think I would like it at first because, again, there's no English in it. It's all subtitled. It was made probably about 10 years ago, so I'm scrolling back in his list of movies here. Oh, these are just movies that he acted in. Let me find movies that he was either the producer or the director on. Apocalypto. He was the producer of Apocalypto. I highly recommend that movie. Who am I? My name is Greg McKay. I live in Henderson, Nevada. That's me. That's my name. I'm getting all carried away here. Anyway, if you want to see a movie that has some cool astronomically related events in it, watch Apocalypto. It's a Mel Gibson movie made in 2006. It's a very strange movie. It's all subtitled, but worth a view. I'm going to grab another screenshot of this inverted image of the sun here. Bear with me, guys, here for a second. I'll get back out to our live view, normal view again here. Alright, we're back live. I am going to drop down into imaging mode though and take a couple of quick snapshots of the sun as we near the end of our eclipse. Anyway, the movie Apocalypto takes place during the time of the Mayans, and you know, there were different groups of Mayans that were all fighting each other, of course. I guess, you know, war has taken place throughout history, every culture, everywhere. And this one group of very much more of a warrior group comes to this village of a fairly peaceful group, and he kidnaps a bunch of this group kidnaps a bunch of these people and brings them a long, long distance way back to their city. And the purpose of them kidnapping these people is to sacrifice them during a total solar eclipse of the sun, which the Mayans were able to predict was going to happen at a very specific time on a very specific day. It's just it's a really amazing movie, and you don't really know anything about the whole reason why these people are being attacked. Until fairly close to the end of the movie. I mean, it's not really a spoiler that gives anything away, because it's still, you know, even with that knowledge, it doesn't really have much to do with the plot of the story. It's more about the journey that these people go through trying to get away from these kidnappers. Yes, Ethan, you should be able to follow me if you're on my page here. Then you should be able to go up to where my name is and click by my name, and it should. Oh, we're seeing some of the power lines at my house here. That faint shadow that you see kind of going across at a diagonal from 8 o'clock to 4 o'clock position here. This is the power lines near my home that the sun is going down behind. But yeah, if you go up to my page somewhere, you should see my name and be able to click on it and follow my name. And it's McKay without the first A there, the way you spelled it. I feel like watching a 2001 A Space Odyssey tonight. Hi, Carrie. Welcome to the feed here. You're just coming in at the tail end here. The eclipse is almost over. But better late than never. Welcome to the group here. I'm trying to open up in another tab here my translate to try to figure out what it is that you're saying here. I can't seem to translate what you're saying or what you're asking there, Carrie. Maybe I don't know if you can type English there. Tell me what you're asking if you're asking a question. So Eclipse is getting very near the end here. I am going to jump out of live view once again here and actually probably go into imaging mode here and just start imaging the moon here for the remainder of the eclipse. So what it's going to do is it's going to take an image every 10 seconds and it will update on the screen here. So rather than a total live view here, because I do want to catch the very end of the eclipse, so it will update the image every 10 seconds or every 15 seconds. You can see the power lines moving out of the way. Coming up on the end. We are about 5 minutes away from the end of the eclipse. So yeah, so if anyone is looking for a great movie to watch related to solar eclipses, Apocalypto. It's a Mel Gibson movie, 2006. You can probably find it on Netflix or somewhere streaming online. It's just it's a great movie. Actually, to me, I think it's probably one of Mel Gibson's better movies. He's not in it. He produced it, and I think he directed it. But still a great movie. I tried to do a translation on what you asked there, and it said already seen in London. I don't know if that's the correct translation. Oh, the eclipse is already over in on Veracruz. Oh, okay. All right. Well, we're a couple of minutes away from it there. Thanks, Steve-O, for the translation. Didn't know you spoke Spanish. And I'm assuming that's Spanish. Looks like we're coming up very near the end here. 4:41 is the 4:41:09 is the scheduled end time of the eclipse here in Henderson. Got about 3 minutes, 4 minutes away. Not seeing my image updating here, so oh yeah, it just did update. It's still going, taking a shot every it's every 15 seconds. That's why. Okay. Veracruz, Mexico. Ah, okay. I tried Google Translate and I don't know if I just copied it wrong or maybe the upside down question mark messed it up, but it said that it mentioned London. I knew that had to be wrong. Very near the end of the solar eclipse here. Once the eclipse is finished here in about 3 or 4 minutes, I will bounce back out of the imaging mode here and give you guys a good close-up of the magnetic storm, the gigantic sunspot there. You can really see it good right now. I'm going to mute my microphone for a second because my wife just walked in and I want to ask her a question. Alright, I'm back. So coming up very near, if you look up at the 11 o'clock position there, you can just see the moon taking its last little bite out of the sun here. A little more than a minute to go. Alright, coming up near the end here. 4109. So we've got about 30 seconds left. Probably that was taking a picture every 15 seconds. That was probably the last image that's going to show any chunk of the moon there. My alarm going off to let me know that the eclipse is over with. Alright. So that's it. I will again, I will dump out of imaging mode here. I'm going to let it make sure I get 1 or 2 images of the sun with no portion of the eclipse taken here. So it's going to take one more picture. Carl was actually asking, do you know? Oh. Well, it's over with here. I would imagine Mexico is probably parallel with us on the same same longitude, roughly. I'm thinking it's probably going to be over with down there as well. All right, so we have got our last good clean image of the sun here. Let me jump out of imaging. I will go back into frame and focus mode here. This is the live view that we're looking at. Let me do a little adjustment on our position here. All right. Let me lock in on that sunspot there and zoom in for you guys. And you get a really good view of the sun, of that magnetic storm. I'll bump it up a little bit in the center here. Well, I think I'm about done. I ended up with 19 viewers total here. 26 was our maximum for the eclipse here. Thanks to everybody that joined in. I think I'm going to sign off here in a minute. Any last questions or comments or anything? Now's the time before I log off. I'll probably be on for another minute or so. Hey, all right, Skip, Joan, glad you guys were able to tune in today. Thanks for coming out and playing with me. I think I'm getting ready to log out here. I'm going to jump back out into full screen live view mode here. Alright guys, I think I'm shutting it down for the night. I'm glad you guys were able to tune in. I'm glad everybody enjoyed the feed. Didn't have too much trouble. I think the software crashed 3 times. Not too bad considering the kludge that I've got running here. Thanks again, and this is Greg signing off from Henderson. Bye.